Hello, CSEC students. Welcome to another live class. This morning, we're going to be algebraic fractions. And an algebraic fraction is pretty similar to a regular fraction, just that we're going to have variables. You know, algebra is all about your variables because we want to find the value of these variables. And that's really the difference, because we're going to be doing the same principles that we would observe when we are adding regular fractions. So for example, we are going to be finding the LCM, just like how we would find the LCM for regular fractions. And then we add the numerator. So after finding the LCM, and you divide the LCM by the denominators and multiply that by the numerators, and then we add the numerators, put it back over the denominator. So I'm going to do work some examples, show you what I'm talking about, and then when we get the answer, we simplify the answers, right? So it's very much similar to what we would do for a regular fraction. So let's start with some algebraic fractions. So let's say we have x over 3 plus x over 5 plus x over, x over 10. All right, so we have the numerators are all x's. In the denominator, we have a 3, 5, and 10. So just like with a regular fraction, we are going to find the LCM. So the LCM of 3, 5, and 10, that would be 30. 3 into 30 goes 10 times. So 10 times x would be 10x. And 5 into 30 goes 6 times. X times 6 would be 6x. 10 into 30 goes 3 times. X times 3 would be 3x. So when we add those up, 10x plus 6x, that's 16x plus 3x, that's 19x. And we put that back over 30. All right, so soak that in and let me know what you think about that. Okay, so look at that. And by the way, if you're having any issues with the stream, let me know, because we've been trying to iron out some issues. So are you seeing clearly? Is it lagging? Are you hearing me well? Let me know that as well. So we had our 3 separate fractions. Each of them had x in the numerator, and in the denominator we had a 3, we had a 5, and we had a 10. Just like with a regular fraction, we find the LCM. So the lowest common multiple of 3, 5, and 10, or the smallest number that 3, 5, and 10 can go into, that is 30. All right, and we divide in LCM by each of the denominators. So 3 into 30 goes 10 times. I will multiply that by the numerator, just like with regular fractions. So 10 times x is 10x, 5 into 30 goes 6 times. And 6 times x is 6x. And 10 into 30 goes 3 times. And x times 3 is 3x, right? So, and then we combine the like terms in the numerator. So 10x plus 6x plus 3x, that gives 19x, and we'll put that over 30. If it's, and this cannot be simplified any further, but if, let's say we had gotten 18x, we could divide both the 18 and the 30 by 6, so we could simplify it further. As is now, this cannot be simplified anymore, so that is the answer. All right, let's do another one. All right, so let's say we have 2x plus x plus 3x, and this is over 7, and that is over 2, and that is over, let's say, 42, right? So we know that the LCM is going to be 42. The LCM of 2, 7, and 42 is 42. So now we're going to divide each of the denominators into the LCM, right? So 42 goes into 42 one time. 2x times 1 is 2x. 2 goes into 42 21 times. X times 21 is 21x. And 7 goes into 42 6 times. And 6 times 3x is 18x. So now we're going to add the numerators. So we now have 2x plus 21x, which is 23x, plus 18x. I believe that is 41x. Double check that for me and let me know. So 41x over 42.
Excuse me, miss.
So 39, right? 41x over 42. All right. So let me know if you have any questions so far. So look at those two that we've done and see if you're following. If you have any questions, just type it in the chat and let me know what are your thought processes. Also, you can type your answers. Type your answers and let me see what you're getting. Okay, so let's proceed then. Everybody seems to be good.
Excuse me, miss.
All right, so let's continue. So let's say we have x over 3 plus 7x over 9 plus 2x over 6. So we need to find the LCM of 3, 9, and 6. The LCM of 3, 9, and 6 would be 18. 3 goes into 18 6 times. X times 6 is 6x. 9 goes into 18 2 times. 7x times 2 is 14x. 6 goes into 18 3 times. 2x times 3 is 6x. So now we're going to add the numerators. 6x plus 14x, that will give 20x plus 6x. So that gives 26x over 18. And we can reduce this using 2. 2 into 18, 9. 2 into 26, 13. And we are allowed in algebraic fractions to leave it as an improper fraction. So that's 13x over 9. We could change it to a mixed number, 1 and 4/9 x, but this is fine as is. You can leave it as 13x over 9. All right, so let's look at some more. Hold on, let me. All right, so let's say we have 2x plus 5 plus 4x over 6 over 8 and over 10. All right. So what's the LCM of 6, 8, and 10? What's the smallest number that 6, 8, and 10 can go into? All right, I believe that's 120. And 10 into 120 goes 12 times. 2x times 12 is 24x. And 8 into 120 goes 15 times. 5 times 15 is 75. No x because there isn't any x up here. And 6 into 120 goes 20 times. So 4x times 20, that will be 80x. So we're going to simplify by adding the x's. So 24x plus 80x, and that gives 104x plus the 75. And that is over 120. Now, this is as simple as it gets because even though there is a number, for example, 5, which we can use to cancel the 75 and the 120, but 5 can't go into 104. When you see the fraction like this, with any number of terms in the numerator, and it's all over something in the denominator, the only way you can cancel them is if you can find a number that can go into all 3 terms, not just 2 of them. Likewise, we could divide these by 4 or by 2, but neither 4 nor 2 can go into the 75, so we can't cancel that way. So this is how we have to leave it. This is how we have to leave it, right, as is. All right, so let's continue. All All right, so this time, let's put the variable in the denominator. So let's say we have 1 over x plus 6 over x plus 1 over 3. All right, so when you're finding the LCM, in this case, the LCM must represent any number of variables that are in the denominator. So we have x and then we have a 3. So the LCM has to represent both. So the LCM is 3x. So x into 3x goes 3 times. And 1 times 3 is 3. X into 3x goes 3 times. 6 3 is 18. And 3 into 3x goes x. So 1 times x is x. So we would have 3 plus 18, so that would be 21 plus x over 3x. All right, so that would be our solution for this one. Let me check the chat to see what's happening. All right. Ngozi says, I don't quite understand what's happening at the top. How did I get 6 at the top? For which one? So I'm dividing the LCM by the denominators. So Jerry is saying it's 30. What is 30? When you're posting your comments, students, please be more specific. Tell me, give me some idea as to which one, because remember the chat kind of lags behind. So be more specific in your comments, and when you're posting your answers. If I have, well, I haven't numbered these, but if I have a number, put the number that you're answering. So Ngozi, how we're getting the top? Remember, the top numbers are the numerators. When we find the LCM, you listening, Ngozi? When we find the LCM, we divide the denominators into the LCM. And the answer that we get, we're going to multiply those by the numerators. So remember, just like with regular fractions, when you're adding them, you find the LCM, then you divide the LCM by each denominator and multiply that answer. Oh. So what did I have for that? Hold on, let me see what Jerry is saying. Let me see which one he's saying. Sorry, that's the wrong thing. All right, so you're talking about which one I had 30. I have so many slides here. Am I on the wrong one? All right. All right, let's continue, and hopefully you'll get it more as we go along. So let's say we have 5 over 3x y plus 4 over 5x. All right, so we need to find our LCM. So remember, when we have variables in the denominator, we want to make sure we represent those variables. So we have an x and a y, we need to put the x and the y. And the LCM of 3 and 5 will be 15. So 3xy into 15xy, that goes 5 times. And 5 times 5, that's 15. 5x into 5xy goes 3y. So 5 into 5, 3, and the x cancel the x, so it's 3y. So 4 times 3y, that's 12y. And we can use 3 to reduce, since 3 can go into 12, 15, and 15. So that will be 5 plus 4y over 5xy. So we have 4 over 7pq plus 3 over 8q. So the LCM of 8 and 7 is 56, and we represent the PQ. So 7pq into 56pq, that goes 8 times, and 4 8s, 32. The PQ cancels the PQ, right? 8q into 56 PQ, so the Q cancels the Q, and 8 into 56 goes 7 times, so we're left with a P, so it's 7P, and 3 times 7P, that's 21P. All right, so that is our answer for this one. We're going to work 2 more and wrap up the addition of algebraic fractions. For now, when we do algebra again, we're going to continue the addition of algebraic fractions next week, because there are more complex ways of expressing these. So let's do 2 more. Lord, I'm all over the place with my slides. My slides are all over the place. All over the place. All right, so I teach so many different classes, and my slides are all over. All right, so we're going to do 2 more. So let's say 6 over 5x plus 2 over 11x plus 7 over x. The LCM of 5 and 11, that's 55. And we know we'd have to represent the x. 5 goes into 55 11 times. And the x cancels the x. So 6 times 11 is 66. 11x into 55x, that goes 5 times. And 2 5s, 10. X into 55x goes 55 times. All right, so 7 5s, 35. 7 5s, 35, and 3, 38. Hopefully I am correct here. All right, so 385 plus 10 plus 66. And that gives 461 over 55x, and that is our answer. That is our answer. As big as it looks, yeah, that's our answer. And we don't need to change it to a mixed number. We are allowed in algebraic fractions to just leave it as is. So let's say y over 10. Why did I choose? I'm not going to choose y because it's going to be difficult to write with that long stroke getting in the way. So I'm going to use, let's say, a over 10 plus a over 6 plus a over 3. So the LCM of 10, 6, and 3, that's 30. 10 goes into 33 times, and a times 3 is 3a. 6 into 30 goes 5 times. A times 5 is 5a. And 3 into 30 goes 10 times. A times 10 is 10a. Okay, so 10a, not 8. 10a. So simplifying the like terms, 3a plus 5a is 8a plus 10a, that's 18a over 30. And this can be reduced. We can divide by 6. So 6 into 18 goes 3. 6 into 30 goes 5. So it's 3a over 5. All right, we have one more slide. So let's use it up. Let's use up the slide. So let's say we have hold on. What is it saying? Oh, why are my slides misbehaving? All right, it's telling me that I'm at the end. So I guess we're at the end. All right, so sometimes my instruments misbehave. All right, so if you understand, just let me know you understand. If not, let me know where along the road you got lost, and we'll come back and get you. So we're going to wrap up this session on addition of algebraic fractions, and we're going to come right back and do subtraction of algebraic fractions.